Good afternoon, everyone. My name is Dakota, and today I'm going to talk to you about creating a street alias address locator for emergency response services in Arizona. There are many rural communities around both the nation and in Arizona with streets that have alias names associated with them that can make it difficult for emergency workers and first responders to locate addresses when a person calls 911 and knows the street by only one name, which may or may not be in an official database. This project set out to explore methods to geolocate addresses based on alias street names and create a workflow document to help communities and counties create their own geolocator to improve response times for emergency services and locate otherwise hard to find addresses. What are alias street names? Some roads have multiple names attached to them but officially go by one name, and non-official names are considered to be alias street names. The alias name can be either similar to the official street name, such as Maple Street versus Maple Avenue, while other aliases can be completely different from the original name. An example of this can be seen on the screen with Wild Game Trail having an alternate name of Wildflower Drive. A common alias issue is with state routes that run through local jurisdictions, such as State Route 260 being known as Main Street in specific towns. What is geocoding? Geocoding is the act of transforming a table of addresses into a feature class with coordinates attached to the address. The table of addresses generally does not have any coordinates available, so it gets run through an address locator that attaches a geographical location to each record in the table. Why is geocoding alias street names important? Not everyone who calls 911 will know the official street name that emergency services has in their database. Sometimes road names change in official sources, and residents may be unaware of the change, and other times they do not know the official name to begin with. This is especially true with county roads in rural areas. Officially, the street name is County Road 110, for example, while someone who lives on the street may call it Orchard Avenue. Geocoding alias street names is very important in cases like this, so that a dispatcher knows exactly where to send help without having to spend additional and oftentimes critical time locating where the house may actually be. It is also important to note that many rural communities have alias street names that are often not in their official address locators due to inequality of resources and funding. Creating a cheap and effective method to locate and geocode alias street names is important for counties with limited budget constraints. For my project goals, it's to research and document alias street names in Navajo County, Arizona, build an address locator that utilizes alias street names manually, and automate the process for extracting alias names from a reference data and building an alias locator. How does geocoding work? Geocoding works by taking a table of addresses and running it through an address locator, which assigns geographical information to the address list. It is important to know address locators are a file that contain a snapshot of reference data that is used for geocoding and provides specialized indexes, rules, configurations, and regional knowledge that allows for a more sophisticated approach to searches as opposed to only performing a database query. The address locator creates a feature class from the table of addresses and attaches coordinate locations to the individual addresses in the table. The coordinates can be used to locate where an address is on a map. Choosing a county. After taking a look at all the counties in Arizona, there were 6 counties in Arizona with alias street names available for use with this project. There were some counties that formatted their alias street names differently, and in the future, these will need to be manually formatted to match the other county formats. Ultimately, Navajo County was chosen as a pilot county due to the availability of alias street names and recent GIS work Terra Systems completed in the county that gave good insight to the need of alias locators in the area. Creating relation tables. One of the most essential steps in building an address locator that can factor in alias street names was the creation of 2 tables in Excel that could be imported into ArcMap. One table is a table of all the original street names, and the second table is a table with the alias street names. A unique ID had to be created for each street name in the original table, so the alias street names could be related back to the original street names, as there were often more than one alias name. The street names were also parsed out into NENA standards, which is the National Emergency Number Association, which is also a federal mandate. An example of how the two relation tables work can be seen in the graphic. The original street name of North Yuma Drive is also known as Yuma Drive North and Yuma Drive. Building an address locator. A dual range address locator was designed using the official road names feature class as the primary table, and the alias name table is the alternate name table. The dual range address locator was chosen because the data provided allowed for finding a house on a specific side of the street, which for emergency services is essential. It was critical to go through and make sure all the fields required for the locator were properly matched the fields in the two tables. It is important to note there was only geographic information attached to the original street name feature class, and it was not needed on the alias name table because of the unique ID relation. Testing the address locator. In order to test the durability of the address locator, 3 tables were created to test the new address locator with alias street names. Addresses that should geocode, which consisted of addresses created that would fit within the street range and match either the alias or original name. Addresses that might geocode, which consisted of streets that have slight address element differences. Addresses that should not geocode, which consisted of names or address ranges that were not in the database. The tables were created using fake addresses that were targeted at fitting in with specific streets and address ranges from the data set. All 3 tables matched as expected. There was a 99% match rate with addresses that should have geocoded, a 71% match rate for addresses that might match, and a 0% match rate for addresses that should not have geocoded. In order to get these results, the tables were run through the newly created address locator tool, which determined the address's location, and the resulting feature class shows if the addresses was matched or unmatched. It was also important to pan to the coordinates and make sure the matched location was accurate. So for the semi-automation approach, while the manual process, with the manual process, the results were expected. It took a substantial amount of time to complete the project manually. In order to increase the efficiency for the other county street alias projects, the process was semi-automated to speed up the time it takes to build an address locator for each county. A Python script was created using PyScripter, and that can be used with Esri software to make the whole process go faster. This for Python scripting. The script that was used for this project utilizes tools already built into Esri software. To run efficiently, the script first creates a new geodatabase, imports the targeted county road feature class into the database, selects the streets in the feature class with alternate names and exports them to a new feature class, removes the streets with no names, creates a summary table, assigns a unique ID, and exports the roads that have alias information into an Excel spreadsheet. In Excel, the roads need to be manually separated into an alias and original street name table. Once an alias table is created, it feeds back into the script, which then uses the table to create an address locator. For reflection, the project set out to create an alias street name geolocator and script that can be utilized to help speed up the process for creating address locator. The project was successful and the alias street name geolocator worked as expected, as did the script. The biggest problem that was encountered in this project was not being able to figure out a way to automatically separate the alias street names from the original street names in Excel, and further research is needed to address that part of the automation. And then do you have any questions?